Hi guys, so in today's video we're going to take a look at indices and at index laws. The first thing to know is that indices are a shorthand used to represent repeated multiplication. For example, 3 times 3 times 3 times 3 can be written in shorthand as 3 superscript 4. If we take a look at a general index expression, a superscript n, we see that it's made of two parts. The number at the bottom is known as the base and is the number that is being multiplied again and again. The number at the top can be known by several names. It's known as either the index, the power, or also as the exponent. This expression would be read as a to the power of n. We'll now take a look at a number of the index laws that make working with indices much easier. The first index law says that if we have the same base raised to two different powers and then multiply each other, then we can write the answer with the base once and the two powers added together. To show how this works, if we have 3 to the power of 3 multiplied by 3 to the power of 2, that is 3 times 3 times 3 multiplied by 3 times 3. When written out like this, it's obvious that the two strings together form one long string that is of length m plus n. So in this case, the answer would be 3 to the power of 3 plus 2 is equal to 3 to the power of 5. The next index law says the opposite. If you have a to the power of m divided by a to the power of n, you take the difference of the two indices. This can obviously also be written in fractional form as a divided by m over a to the power of n equals a to the power of m minus n. To see this in action, we could take 5 to the power of 7 and divide by 5 to the power of 2, and expanding that out we would have 5 times 5 times 5 times 5 times 5 times 5 times 5 divided by 5 times 5. And we can see that in this case some of the 5's on the top and bottom are going to cancel, and whatever number we had on the top we're taking away however many there were on the bottom, and what this leaves us with is a string of 5's where we had 7 and we took away 2, and we've now got 5 multiplied by itself 5 times. Our next index law states that if we take a power of a power, so a to the m to the power of n, that we can just multiply the two powers together. So for example, if we had 4 to the power of 4 raised to the power of 3, then what that would be is 4 to the power of 4 multiplied by 4 to the power of 4 multiplied by 4 to the power of 4. And as we've already seen, when we have index expressions multiplied together, we can add all of the indices. So in this case, we would have 3 lots of 4, which is our rule, and that would give us 4 to the power of 12. Our next index law says that the product of two numbers, a and b, raised to the power of n is equal to the product of the two individual index expressions, a to the power of n multiplied by b to the power of n. We can see this if we have xy to the power of 3 equals xy times xy times xy. Obviously, this is just a string of multiplications, x times y times x times y times x times y. And we can write multiplication in any order we like. So what we do is we rearrange to have x times x times x times y times y times y. And this is then equal to x cubed times y cubed, proving that our rule works. This same principle applies for the quotient or division of two numbers a and b. We can separate a quotient raised to the power of n into a to the power of n divided by b to the power of n. Again, we see it in the same way. X divided by y to the power of 3 is equal to x divided by y multiplied by x divided by y multiplied by x divided by y, And following the rules of multiplying fractions, we multiply all the top terms together, giving us x cubed, and we multiply all the denominators together, getting y cubed. One of our final index laws is that a to the power of negative n is just another way of saying 1 divided by a to the power of n. This rule is actually connected to another basic index law, which is that any base to the power of 0 is equal to 1. So if we have 3 to the power of negative 5, we can rewrite that as 3 to the power of 0 minus 5. And as we know, in this case, that would give us 3 to the power of 0 divided by 3 to the power of 5. And as we've just seen, 3 to the power of 0 is 1, which would give us 1 over 3 to the power of 5. Another index law that's kind of an obvious statement is that any number to the power of 1 is just itself. And our final index law is actually rather an interesting one, and that's that a to a fractional power is actually the nth root of a. So for example, if we have 3 to the power of 1/2, that equals the square root of 3. And it's easy to see how this works. 3 to the power of 1/2 times 3 to the power of 1/2 has to equal 3 to the power of 1/2 plus 1/2. But that's just 3 to the power of 1, or 3. So we've got two numbers, 3 to the power of 1/2, identical numbers, multiplied to give the answer 3. That's the very definition of how a square root works. Square root 3 times square root 3 is equal to 3. We can also combine this last law with our earlier power law and say that a to the power of n over m is equal to the mth root of a to the power of n, or the nth power of the mth root of a. So for example, 3 to the power of 3/5 would be 3 to the power of 3, and then we take the 5th root of that, or we take the 5th root of 3 and raise the entire answer to the power of 3. And here I've just written all of those index laws again for you as one last summary.